Humanity has always gazed at the night sky, captivated by the endless expanse above us, wondering what secrets it holds. Driven by curiosity about what lies beyond, we have always sought to understand our place in the universe. For centuries, our only tools were our eyes, until the invention of the telescope brought the universe closer, transforming our understanding of the cosmos. Each new telescope revealed more: planets, moons, and distant wonders we never imagined. Galaxies, billions of them, appeared before us, expanding our understanding of the cosmos and our own existence. The Hubble Space Telescope revolutionized astronomy, giving us breathtaking images and insights that changed science forever. It revealed the universe's age and scale, showing us just how vast and ancient everything truly is. But Hubble saw mostly invisible light, limiting how far back in time we could see. To look further back in time, to the universe's earliest moments, we needed to see in infrared, light invisible to our eyes but rich with secrets. Enter the James Webb Space Telescope, or JWS, the most powerful space observatory ever built, a marvel of modern engineering and ambition. Its golden mirror, 1,000,000 miles from Earth, is designed to capture the faintest whispers of ancient light, traveling across the cosmos for billions of years. Webb's mission: to peer over 13 billion years into the past, watch galaxies form, and witness the universe's first light. It will witness the birth of stars, unraveling the mysteries of how solar systems like our own come to be. And it will search for the building blocks of life on distant worlds, analyzing the atmospheres of exoplanets for signs of habitability. JWS is not just Hubble's successor, it's a leap into a new era, opening doors to discoveries we can only dream of. It is both a time machine and a cosmic laboratory, allowing us to study the universe's history and its ongoing evolution. With Webb, we're not just looking at stars, we're analyzing them, decoding their secrets, and searching for new worlds. We are searching for answers to the oldest question: are we alone, or is life waiting to be discovered elsewhere in the cosmos? This magnificent instrument is our generation's contribution to the timeless quest for cosmic understanding, a beacon of hope and discovery for all humanity. Orbiting a faint red dwarf star in the constellation, Leo, some 124 light-years from Earth, is a planet that has captured the imagination of astronomers worldwide: K2-18B. This distant world circles a star much cooler and dimmer than our Sun, in a region of space that, until recently, was largely unexplored. While it may not have the household recognition of Mars or Venus, K2-18b has quickly become a world of immense scientific interest, drawing attention from researchers eager to unlock its secrets. Discovered by the Kepler Space Telescope during its extended K2 mission, K2-18b is classified as a sub-Neptune, meaning it's larger than Earth but smaller than Neptune, and it doesn't resemble any planet in our own solar system. Its unique size and composition set it apart as a rare type of exoplanet, weighing in at about 8.6 times the mass of Earth and stretching 2.6 times wider. K2-18b is a fascinating object of study. Its size suggests a thick atmosphere, possibly rich in hydrogen, and a structure that could include both rocky and icy layers. What truly excites scientists, though, is its location. K2-18b orbits within the so-called habitable zone of its star, the region where temperatures might allow liquid water to exist on a planet's surface, a crucial ingredient for life as we know it. Liquid water is essential for life, but simply being in the right place isn't enough. A planet also needs the right kind of atmosphere and chemistry to support life, and these factors are far more complex to detect and understand from afar. Earlier observations by the Hubble Space Telescope hinted at the presence of water vapor in K2-18b's atmosphere, sparking excitement and making it a high-priority target for the next generation of telescopes. The James Webb Space Telescope, with its advanced instruments and unprecedented sensitivity, is now poised to confirm these tantalizing hints and search for even more complex molecules, potential signs of habitability or even life. K2-18b has become the perfect test case for Webb's capabilities, a world in the habitable zone, larger than Earth with intriguing signs of water vapor in its air. It stands as a bridge between rocky planets and gas giants, offering a unique laboratory for studying planetary atmospheres. The scientific community waited eagerly, watching as new data arrived. Could Webb finally reveal what this distant world is truly made of? Would it show us a planet with the right conditions for life or something entirely unexpected? The investigation of K2-18B isn't just about understanding one planet, it's about testing our ability to find habitable environments across the galaxy and refining the tools and techniques that will guide future discoveries. Each discovery here is a step forward in our cosmic exploration, bringing us closer to answering the age-old question, are we alone in the universe? K2-18B represents a bold new frontier in the search for life beyond Earth, a beacon for future missions and a symbol of our curiosity. The stakes couldn't be higher, as every new piece of information brings us closer to understanding our place in the cosmos. Studying a planet 124 light-years away is a technical marvel. We can't see K2-18B directly. It's just a faint point lost in its star's glare. Webb uses transmission spectroscopy as the planet transits its star. Starlight filters through its atmosphere. Molecules in the air absorb specific wavelengths, creating a chemical barcode in the light. By capturing this spectrum, Webb reveals which gases are present, analyzing the breadth of a world from trillions of miles away. Webb observed several transits collecting faint light that traveled over a century to reach its mirror. Scientists painstakingly filtered out the star's light, isolating the planet's atmospheric signal. The anticipation was immense. Every dip in the spectrum was a clue. Webb confirmed what Hubble hinted. K2-18B's atmosphere is rich in water vapor. But this was just the beginning. The data held even more surprising secrets. Webb's data revealed more than water. K2-18B's atmosphere is rich in carbon-bearing molecules like methane and carbon dioxide. On Earth, these gases are linked to life and geology. Their presence here suggests a carbon-rich, hydrogen-dominated atmosphere. The mix of methane, CO2, and lack of ammonia hints at a complex environment, possibly with a liquid water ocean beneath the atmosphere. This was a game-changer. K2-18B might not be a gas dwarf, but something new, a Hycean world. Hycean planets are theorized to have hydrogen-rich atmospheres and global oceans. Such worlds could be very different from Earth, but still potentially habitable. Webb's findings provided the first strong evidence that Hycean worlds might actually exist. This discovery opened a new category of planets in our search for life. The universe just got a lot more interesting. Webb's analysis of K2-18B's atmosphere was already groundbreaking, but then came a faint, tantalizing signal dimethyl sulfide, or DMS. On Earth, DMS is produced almost exclusively by life, by ocean-dwelling organisms. The detection was tentative, needing confirmation, but the possibility electrified scientists. Unlike methane or CO2, DMS has no known significant non-biological source on Earth. If confirmed, it would be the strongest evidence yet for life beyond our planet. Suddenly, K2-18B wasn't just potentially habitable. It was a prime candidate for hosting life. The search for life had a new specific target. The universe felt a little less lonely. The evidence, water vapor, carbon molecules, and a hint of DMS, paints K2-18B as a true water world. These molecules, detected by the James Webb Space Telescope, suggest a planet with a dynamic, active atmosphere and the potential for complex chemistry. Imagine a planet-spanning ocean beneath a thick, hydrogen-rich sky, glowing faintly under a red dwarf sun. The light would be dim and tinted red, casting an otherworldly glow across endless waves, creating a scene both alien and beautiful. The air would be unbreathable, the gravity stronger, the pressure immense. Any visitor would feel the weight of the atmosphere pressing down, and the sky above would seem heavy and close, unlike anything on Earth. Yet within this alien environment, conditions could be just right for life. Microbial life might thrive in the deep, dark waters, adapting to the unique chemistry and energy sources available. The ocean could shield organisms from radiation, while the atmosphere traps heat, keeping water liquid. This natural insulation creates a stable environment, protecting life from the harshness of space and the stars' flares. Webb's data supports the Hycean world hypothesis, a hydrogen atmosphere in direct contact with a vast ocean. This unique combination could make these worlds more common and more habitable than previously thought. The lack of ammonia is another clue. Ammonia dissolves in water, so its absence suggests a large ocean. This chemical fingerprint hints at a planet where water dominates the surface and shapes the atmosphere. K2-18B is fundamentally different from Earth but may be just as habitable. Its alien conditions could support life forms unlike any we know, expanding our understanding of what it means for a planet to be habitable. Our search for life is expanding beyond Earth-like worlds. We are now looking for life in places we never imagined possible, guided by new discoveries and advanced telescopes. Hycean planets could be common, vastly increasing the number of possible homes for life. The universe may be teeming with ocean worlds, each with its own mysteries and potential for life. It's a paradigm shift in astrobiology. The search for life is no longer limited to Earth-like planets, but now includes a whole new class of worlds, Hycean planets, reshaping our place in the cosmos. The Hycean world concept is new, but K2-18B fits the profile perfectly. These planets are larger than Earth, with global oceans and hydrogen-rich atmospheres. At first they seemed inhospitable, but models show their conditions could be stable and life-friendly. The thick hydrogen atmosphere acts as a greenhouse, keeping water liquid even far from the star. Webb's findings on K2-18B are the first real evidence supporting the Hycean theory. Now astronomers can search for more Hycean candidates among thousands of exoplanets. The universe may be filled with habitable worlds we never imagined. K2-18B is the poster child for this new frontier. Webb's discoveries on K2-18B bring us closer than ever to answering, are we alone? The findings don't prove life exists there, but they're the most significant step yet. The potential detection of DMS is a powerful biosignature. If confirmed, it would be historic. Even without DMS, confirming a Hycean water world with a carbon-rich atmosphere is monumental. It shows habitable environments can exist in forms very different from Earth. If Hycean worlds are common, the galaxy could be teeming with life. The search for life is now a testable scientific hypothesis, not just a philosophical question. We have the tools to find answers. The universe feels more alive with possibility than ever before. Webb's analysis of K2-18B marks a new era in cosmic exploration. This is just the beginning. Next, Webb will observe K2-18B again, seeking to confirm DMS and refine our understanding of its atmosphere. Other sub-Neptune exoplanets in habitable zones will become prime targets. We're no longer searching blindly, we're conducting a systematic survey guided by evidence. Each discovery builds on the last, inspiring even more powerful future telescopes. Imagine one day directly imaging continents and oceans on distant worlds. The story of K2-18B reminds us why we explore. To understand the universe and our place in it, we stand on the verge of answering one of humanity's oldest questions. The journey ahead is long, but for the first time we have a clear path forward. The cosmic story is still being written, and we're turning a thrilling new page.